Hello, you amazing hackers. This is James Beers. This is course number 2. We're going to be doing this course. This course is called Bad Bash. Okay? And Bash is a language that's found inside of the Linux Unix operating system. All right? First of all, let me go through my credentials. I have an Associates of Applied Science in Information Technology and Networking. I've been doing bug bounties for just about 4 years now. I work professionally as a programmer and a pen tester with the thexssrat. And so, I mean, if you're looking at learning from me, this is the place to do it. In this course, we're going to go from beginner. What is Linux? You know, what does Linux do? What is it? All the way to writing your own bash scripts with awk augmentations and sed augmentations. Now, you might not know what that means right now, but you will by the end of this course. So the first thing we're going to do is we're going to look at what is Linux. See how this says Linux parrot? What is Linux? This is a Debian. These are all words that I don't know. x86, 64, GNU Linux. What does that mean? Well, Linux is an operating system like Windows. Okay, it's written on a different code. It's written in a more hardware-friendly way, and it just does things better. Windows is great for playing video games, but if you want to do something with computers, usually Linux is the way to go. Linux or Mac. There are attachments for Windows and stuff like that, and there's WSL for Windows now, so it's not that bad, but it's better on Linux. Debian is a flavor of Linux. It's like saying blueberry flavored gum. You know, it's just a flavor. x86 64 is a 64-bit operating system. And GNU Linux stands for, I think, hold on. GNU Linux is the UI. It's the GUI, the graphics user interface, for the Linux version that I have. There's different ones. Yeah. So that's what Linux is in a nutshell. And what we're going to be looking at is what Bash is. So this is your Linux desktop, right? It looks like a regular desktop. You can even go to files and stuff. But most of your time as a hacker is going to be right here in this area. Okay, so this terminal is where we're going to live. In the next video, I will start showing you some slides. Yay! And I'll start showing you some things in the terminal that we can use to feel our way around different areas. Welcome back to lesson 1. What is Bash? Okay, so we've already went over Linux and what Linux is. This is what Bash is. Bash is an abbreviation of Born Again Shell. It's the most common interactive interpreter command prompt and has had a long history. What does that mean? That just means that it's the most common command prompt in Unix and Linux. Unix shell or Thompson shell had been burned. Unix shell is very small and had some small features. Born Again Shell doesn't have that problem. If you would like to read more about this, you can. Bash is not the Windows terminal. Okay, Linux allows Bash one-liners and scripts. Demo. A one-liner looks something like this. Let me move my mic here. Sudo apt update, and then sudo apt upgrade. Now what this command is going to do is it's going to run this, and if this is successful, that's what this means right here. So if this is successful, then it's going to go ahead and run the second command. Now, I'm not going to run this because I've already upgraded my machine, but that's what a one-liner is. Okay, a one-liner is literally where you write bash script in one line. It could look a little something like this. For I in, and then some backticks, cat, this dot text, another backtick, in the statement, do, command here, in the statement, done. That is another way of running a one-liner. We're going to see a lot of this coming up in the following lessons, but in lesson 1, I just want you guys to get a feel of what you're going to learn, okay? What you're going to learn. Bash is how you interact with most of the information from the tools you're going to run. Bash has the ability to be very versatile. You can do lots of things with Bash inside the Linux operating system. They even have man commands, so I can say man ls and it will tell me all of the options that I can use with ls, which is list. It stands for list. So if I ls right here, I can see all of the things in this file. If I want it neater, I can say ls tac la and it'll make it a little bit neater. There's ways to make it into a separated file list, all kinds of those other things. But we'll get into that, of course, in the later lesson. Bash has lots of great commands. Here's a resource right here. You guys can check out this PowerPoint. It comes with the course. Definitely go check out all of the Bash commands for hackers. They're really cool. We're going to teach you a lot of them in here, but I believe that self-learning really cements things in your brain. So please self-learn while you're going through this. There are going to be things that you're going to have to complete and turn in. There's an awk test and there's a bash scripting test. So I want you to take a bash script that you make yourself and automate something that you do in Linux, or something you can do in Linux. We've already went over man. This is the command that will show you the documentation for any command after it. Man ls, we did that. Ls is list. Touch, we can touch a file and it'll create a file. So let's make a directory first with make dir. And we're going to say course, bash course. Let's say bash course. Now we're going to go into bash course. Okay. And now we're just going to say touch this dot text. And now if we ls in here, you can see that this dot text has been created, but there's no data in it, okay? That's because what touch does is it creates the file. It's perfect for one-liners and when you just need to make a file to dump some information into. Touch is amazing for that, okay? grep is a command that filters things. Dig into grep commands. We're going to be going deeply into these commands in the second lesson, so I'm not going to demo each one, but I do want you to be aware of the names. I want you to be aware of what we're going to be learning. Cat outputs the file of a text file. So if I was to echo this is a test file into this dot text, now if I cat this dot text, as you can see, it prints out what's inside of the text file, right? It's perfect. There's other things you can do with cat. Use it in one-liners like this. The pipe commander, the pipe operator, we're going to get into that. There's the ampersand. It runs the command after it without checking if the command before it completed. This is the double ampersand that we saw a little bit earlier with the one-liner. And it executes the following command, as we remember, only if the command before it is completed with no errors. Can't have any errors in the command before it. There's a double caret, which appends. So appends means it adds to the end of a text file. And there's the single caret that will overwrite files or create files. You can move files. MV is how you move files. CP is how you copy files, but you can also rename files with the MV. We'll get into that later as well. Sudo is a command if you need to use root privileges. Cut is for filtering information. which is mostly what this course is about. It's Bad Bash. I'm going to teach you how to filter information, and I'm going to teach you how to automate the tools that you're using. So you can use both of those things together to pull more bugs out, to learn more about what methodology you want to set up for yourself in any given situation. It's all about science, right? And you need the data for science. So here's the data. CD is how you change directories. It's how you change directories inside of a Linux area, a Linux terminal. Awk is a programming language that runs inside of Bash. Most Linux distros have Awk, and we're going to have our own section on Awk where you write out your own Awk stuff. In the next lesson, like it says, I'm going to break down all the commands and show you all the cool things you can do with them. I just wanted you guys to be aware of the simple commands. That way when we start diving into what we can do with these commands, you guys aren't overwhelmed, okay? Because the next lesson is kind of huge. We're going to have lots of videos, there's lots of PowerPoints, and there's lots of demos for me to show you guys what's going on, to get you guys up to the point where you can understand and write a script. So thank you so much for being here, and we're gonna hit it with the next video, guys. We're just gonna hit it with the next video. I'll see you guys at the next video. Lesson 1 is over. Lesson 2 is starting on the next video. Hey guys, welcome to lesson 2, and this is all about the terminal and the commands that we use. So let's take a look at ls. Sorry. ls is a command that lists. It lists directories, okay? So if we go ls // it's going to list the / directory no matter what directory we're in, okay? If we try and ls the root directory, it will list the root directory. But we can't, I don't think we can cd into the root directory. Oh, I guess we are the root user. Okay. Anyway, so ls will only list the folders that you have permissions to, is what I'm getting at. If I didn't have permissions to the root directory, it wouldn't let me list it. Okay, but I can list Etsy, I can list my home directory, which is the one that I'm in. Okay, and I can basically from one terminal spot, I can look at all of the files. Okay, this is the home directory, right? And this is just ls. We can do ls tech la, and we can list all of the permissions for the files. They're located right here. These are the permissions for all the files. The first one is the root. The creator has read, write, execute. And then the second one is the group. And then the third one is everybody. Okay, so that's how they go. This one is the creator. This one is the group. This one is everybody. And it's read, write, execute, read, write, execute, read, write, execute. Pretty cool. Pretty awesome. These are symlinks right here. So they're symlinked to execute certain things, which is fine. This is just what LSLA looks like. You get a lot of the other files, the dot files in there. It just looks very nice. ls tech a will not do lsla, but it won't give you all the permissions, but it will give you the dot files, the hidden files. Okay, so then if you do ls tech la, then you can see it's listing the permissions, and it's giving you all of the files that are actually in the directory. Okay, so that's ls. ls is how we see where we are inside of an area. Let's talk about mkdir, make dir. Okay, you can just say mkdir. Let's call it lesson 2. Oh, because I'm in the root directory. See, I don't have permission to create in there. So now I'm going to go back to my home file. This is my home file right here. And lstech.la should show you all of the hidden files. You see all these hidden files: KDE, local, Emacs, DMRC, bash history, cache config. There should be a .zsr8rc, ZSHRC right here. So the .zshrc is going to be important later, so just understand that that's in your home directory. We're going to make some aliases for some tools and make our own commands that way. But right now, we're talking about making a directory. Okay, mkdir lesson 2, and now we've made that directory. If we say ls again, you can see that we've made lesson 2 right here. Okay. So let's use another command that we learned about, which is cd, change directory. Okay, let's change directory into lesson 2. And it's case sensitive with Linux. So if I was to make a directory and say test, and make a directory and say test, those are two different directories. If I try to cd into test, it won't put me into the one with the capital T. If I cd ... which if you look at lstech.la, ... is the second file here. That means go one folder up. The dot is this folder. So this folder, one folder above it, test and test. Okay. So if we cd into capital test, we can see that we actually are brought into capital test. Okay, cd ... Now, one thing that's really cool about making directories is you can order things in your terminal the way that you want it to look here, right? Which is awesome. Let's check out the syllabus. We have ls. We just did cd. Okay, we're going to do some grepping, some catting, some copying, and some piping. Okay. So let's use touch. Actually, let's use echo. Let's echo out something like this is a test file for lesson 2. Okay. And then we're going to use our arrow operator, and we're going to write that to test.text. That's not a dot. Text. Okay. Now we should have test.text. All right. So if we use cat, we can cat out or concatenate. Is that it? Is that what cat stands for? I don't know. It reads the file. It reads the text file, and it takes the internals of whatever's in there and prints it out on the screen like this. See how it printed it out like that? Okay, so we can actually take that and pipe that into a function. Wait, hold on. Let's add some more lines. We're going to use the double arrow operator now. And we're going to say adding a line to test text file. Okay. And we're going to use the double arrow operator and put that in test.text. Okay. And now we can cat it back out again, and you can see we added that second line. So what does the double arrow operator do? It's going to append our output on the terminal into the file that we tell it to. Okay? So the single arrow will actually rewrite it. Like if we were to do this one again right here, it's going to rewrite what we did. See? It rewrites the whole file. So if you want to rewrite a file on the fly, this is a really good way to do it with the single arrow operator right here. Let's go back and add our second line. Okay. Now let's cat test.text, and let's pipe it into a grep function. Let's grep for, what are we going to grep for, right? Grep is like searching the output text for whatever you put in here. So we'll say line, and it only returns the line with line in it. Okay, do the same thing if we say lesson. We'll get the first line, right? What about grep tac v lesson? What did that do? That took that line out and gave us everything but that line. Okay? And this is very useful when you're going through a whole lot of data, like subdomains, GAU output, things like that. You want to grep for your results. You want to grep for the things that you want, because it would look something like cat your results file, like your URLs and stuff, right? And I want to take out anything that has anything that has 404 in it, or I want to take out anything. I want to take out anything that I have already identified in the file that is not what I'm looking for. Like if I have a scope and it's mixed with different domains, then I would take the not wanted domain here, right? And I would put quotes around it. And then that would filter out everything. It would filter out this domain right here, right? It would filter this domain out from the list, and I would get just lines without that domain. Or you can use grep and use the operators inside of grep and use a $JS. This would give you anything that begins with JS. That's not really useful, but it is useful if you put HTTPS here, right? Okay, let's take this handy dandy $, and let's put it back over here. Let's put it over here, and then we'll put JS here, and now we're getting anything that ends in JS, like a .js file. JavaScript files are important. There we go, boom, right? So this little operator we've been using, this little thing, is called the pipe operator. Okay, we have the PowerPoint on the pipe operator. There's some commands in there and stuff. If you're unclear about the pipe operator, please use man command. The man command can, I'll show you. If I just man the pipe operator. Oh. This is the pipe operator. It tells you what it does. It tells you how it channels it, everything, right? We can come out of here and we can man CP, and it'll give you the rundown of all of the things that copy can do. Okay, copy has some pretty intense things. You can force a copy of a file, you can link a copy of a file, things like that. So let's look at our, we just did grep, we did cat, we covered pipe, right? The pipe operator is the thing that carries the output from one command and puts it into the other command. So the output from cat would usually just be these two lines, but instead we're putting it through this operation with the pipe operator. Okay? CP, obviously CP copies things, so we can say CP test.text and output that, or no, we don't need to output it, we just put our second level test2.text, and we should have two files here now, test and test2. We copied test2 over. Now I can't copy test.text over to test.text. I think it'll give me an error and it'll say, hey, they're the same file, right? Can't do that. So how do we rename a file? Like, say I named this file not what I wanted to name it. How do we rename a file? We're going to use the move operator right here. Okay? Oh, move, MV. We're going to use the move operator. I have copy on here twice. We're gonna only go through it once though. I have the move operator, and the move operator, I can just go mv, which is move, the file I want to move, which is test.txt, okay, and then I can move it into test, and then I'll put a / and say renamed dot text. Well, that doesn't seem right. No such file or directory. Hold on. No, because that would defeat the purpose. We should be able to create it right here. Maybe I'm doing it wrong. Maybe it's /test /renamed dot text, and then this is test.txt. No. Rename.text. There we go. So I can do it in the same folder. I could rename the file. Let's do it with test2. We'll take test2 and rename it to test. So we still have a test. Okay. So we can use the move function to move files. If we say mv tech_r test to this directory, what this command would do is it would move recursively this directory to my directory, all of the files. It's a handy dandy little trick when you're trying to scrape data off of a server. The ampersand sign. The ampersand sign is like this: sudo update and sudo upgrade. So what this is going to do is this is going to run this command, and then even if this command comes back with an error, it's going to run this command right after it. It doesn't matter. So don't have your second command with this rely on anything from the first command. Okay? If I was to go like this with a double ampersand and say sudo update and then sudo upgrade, now it's only going to do this command if this command is complete and completes with no errors. Later on in this lesson plan, probably the next lesson, we're going to start digging into how I use these commands on a daily basis as a penetration tester and as a hacker. They are all very, very, very useful, and I just wanted to sit down and show you guys how they all work. And there's extensive PowerPoints on them. I wanted to be sure that you guys at least knew these commands before we went forward, because what we're about to get into is scripting in Bash and scripting our own commands. And so I really want you to be comfortable with running and reading and understanding what your terminal is doing. Okay? So I will see you in the next lesson, lesson 3, on how to make your own commands. Hi guys, welcome back. This is lesson 3, how to make your own commands. So let's say we have a .py file, right? A Python file, or even let's say that we have a Python tool, right? Like HackCrawler. HackCrawler is a Python tool, okay? And in order to use that tool, we have to download it, install it, right? And then make an alias for it. So let's do that. Firefox is loading up. There we go. I think it's a Python file. It's made by Hack Luke. Very awesome. Oh, it's a Go file. Yeah. Everybody's going back over to Go. So, let's try and find one that's not a Go file. Link Finder. This is a Python script. Okay, so in order to install this script, we need to download it somewhere. So let's grab the code. Let's copy this file. Let's go over to our terminal and let's say git clone and the link that we copied. If you guys want to know how you do that, it's Control-Shift-V and it'll paste whatever you just copied. So now we have a link finder inside of here, right? And if we go into link finder, we can see that there's a link finder py. Now, if we just run link finder, it's command not found, right? Well, I don't want to have to go to this file and this I don't want to have to go through all this just to run this tool. So we're going to go into our home directory. Okay. Let me clear all this off the screen. We're going to say sudo nano or vim, whichever one you want, .zshrc. And we're going to put our password in there. And you can see right here it says alias ls, right? Color auto, blah, 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 right? So this is where they're putting their aliases. Is that all of the aliases? I think that is the alias section. Yes, that's the alias section. So what we're going to do here is we're going to say alias link finder, okay, equals, and we're going to put our command in here. All right, and we're going to say it equals Python 3 /home / Nemo / no period / where's the other one? Right here, and we'll go into lesson 2. And link finder. And okay, so Nemo lesson 2. Remember, it's case sensitive. Link finder / and now we'll go back over here and see if it's capitalized in that. It's not. So then we'll say link finder dot py, and then we'll save this. We'll exit out of it. We're going to say source .zshrc, and it's going to source that ZSHRC, and now we can say link finder, and we have, see, it's trying to go to it, but it's saying that it doesn't have JS Beautifier because I didn't install the files to run it, but it is calling this Python file. Okay. To prove that, why don't we do this? Why don't we say Python 3 tacm. Nope, we can just do pip3 now. Pip3 install tac-r requirements.txt. There it is. It's installing everything. The JS Beautifier, that's done. That's done. There we go. Now when we run it, it's going to say the following arguments are required, and it has the little input and everything. So that's the exact thing. Let's run the help file just to make sure that there it is. So it's actually accessing it directly with link finder through our command, through our alias. Okay, I hope that makes sense to you guys when you're dealing with Go repositories. Here, let me show you. Let me show you down here at the bottom what I did. This is what you need to do for your Go repositories. You need to set it up like this, so your Go repositories will run automatically. You won't have to make aliases for all the Go repositories. That's how you make your own commands. Okay, there's a PowerPoint on this. I encourage self-learning. If you guys want to know any more about the alias or anything like that, definitely self-learn about it. Dig into Google how to set an alias, how to take an alias away, those types of things. Permanently setting aliases, permanently updating your ZSH. It's very handy when you're dealing with new operating systems, new Linux systems that you're not used to handling. Okay, I will see you guys on the next lesson. The next lesson is, I think it's scripting, actually. Let's check it out here. The next lesson, making your own commands. awk is incoming. We're gonna have awk at the end of this. Sed is the next lesson. Okay, so we'll do a sed video next. And then once you guys learn sed, then we'll work on script writing and automation of tools. Okay? I'll see you guys in the next lesson.
Welcome to Chapter 2 of this course, where we will take a closer look at the general structure of an awk command, as well as print some stuff out into the terminal. First of all, I have made a small text file here. It's called people.txt and it consists of 3 rows, an ID, a name and a last name. We're gonna do some very basic exercises with this just to get you used to using awk. Say, I want to just print the name and the last name row. I can do that very easily with awk. First of all, we need to know that awk processes text in rows. So this will be the first row, this will be the second, and this will be the third row. Now, if I want only the last 2, I can cat my file, then I can pipe it into awk, and now I'm gonna wrap my awk command in single quotes, and now I'm gonna use curly braces. Those curly braces wrap around my body, so the awk code that I want to execute. And here I'm gonna say print $2 because I want the second row, and awk starts counting at 1. Then I want to print space, and then I want to print the third row. So I'm gonna say $3. Now if I hit enter, I only get the last 2 rows. It wasn't too hard, was it? But there is more to awk. Awk also has a begin section, and awk also has an end section. The begin section ensures that the code that is run before any input is processed, so right on startup, and only executed once. And the end section makes sure that all the code that is run after all the input is processed. Those 2 sections are optional, but you need them in some case. For example, if you want to define a variable and print it out, you would need to use the begin section. Otherwise, awk will constantly wait for input. But we're not going to worry too much about that now. Let's look at another method of printing something. If you've ever used the C language before, you may be familiar with the printf command. Well, awk has the same thing. You can just say printf and then specify a format string. So we can say something like %s, and now we can pass the rows we want to print as an argument. So $2, comma, $3, just like that. And we also need to add a new line character. If we press enter, we get the exact same result. The %s is used for printing strings, where if you want to print an integer, you would use %d and %f for a float. Alright, let's say that our file isn't separated by white spaces, but instead by commas, like here. You can see my rows are now separated by a comma. If we try to run our awk command again, it will fail, because by default awk uses the white space as a separator. So we will need to tell awk to use a comma instead. We can do so, getting our file, calling awk, but this time we're gonna say tag capital F. We're gonna give it a comma right here. Now awk knows to use a comma as a field separator. If I retype my command, my curly braces, and I say printf %s, %s, don't forget the new line. And now I'm gonna add my arguments, $2 and $3. It still works as expected. Now, instead of just writing our awk commands in the terminal, we can also write them into a file, which comes in handy if your code gets bigger. To do so, simply open up your favorite text editor. I'm using Vim, but you don't have to. Just gonna create a file called test.awk. And in this file, I can just write my awk commands. This time, however, I don't have to wrap everything in single quotes since we are no longer in the terminal. So, again, if I want to print the second and third row, I can just use my curly braces to define my body. And I can just say printf %s, %s, don't forget the new line. And again, just give whatever I want to print as an argument. And that's it. Now I can save this file and close it. And now I can execute it. I can say cat. I'm going to use my people.txt file. I'm going to say awk, tag small f, and then the file where my commands are written. So in this case, it's test.awk. And it works. There is also another way of applying the awk instructions to a file. You don't have to cat the file and pipe it into awk. You can also call it directly, where you can just say people.txt. Works the same way. I typically cat my file and pipe it into awk, but that's really just personal preference. Now awk also features a lot of built-in variables, which we can use, for example, to query system information. One of those variables is called environ. With environ, we get access to all the system environment variables. We can use it as follows. Awk, again, we need the begin keyword here. And we can say print environ, all caps. And then we're going to need to specify what environment variable we want. And we want the user variable, for example. And press enter. And I'm going to get 0x prototype. And I can check that that is correct by typing echo $user. And yes, that is correct. Now let's take a look at the increment operator. The increment operator is just like in any other programming language, a simple plus plus. Now, there is a difference between a post and a pre-increment, and we're going to take a look at that. First, let's look at the post increment. We define a variable called x and assign the value 1 to it. Then we define a second variable called y, and we set the value to the increment of x. Note here, if the pluses come after the variable, it's a post increment. And then we print the result. So if I run the script, I get x is 2 and y is only 1. That is the case because in a post increment, awk returns the value first and then increments it. So here y simply gets set to 1 and it stays 1. If we take a look at a pre-increment, like here, where the pluses are in front of the variable, awk will first increment x and then return it. That is why when we run this script, y is also 2. Now, many other programming languages have a string concat operator. Usually, if you want to concatenate strings in other programming languages, you would use the plus sign. In awk, you don't do that. You don't have a string concatenator. Instead, as you can see right here in the terminal, you just write out your expressions after another. So I define a variable called x, where I write awk is so, and then in my variable y, I write useful. And then I can just print them out. That is how you would concatenate a string, or really any value, in awk. If you would make the mistake of writing print x plus y, you would get a 0, because you can't add strings together. Welcome to chapter 4, where we will take a look at arrays. As you can already see, I've prepared a small example. Let's go over it. So, if we want to use an array, we have to define it and assign a value. First, we have the name of the array. In this case, I just called it my array. Then we're going to specify an index. We do this by using brackets. And then we assign a value. So we assign what we want to have at that place in the array. Arrays start at 0. That is important. So when I'm referencing to the first place in an array, it's always going to be at index 0. And our array at its first place will have the entry dog. And at the second place, so at index 1, it will have the entry cat. And then we can just print them out. We can access places in our array simply by specifying an index. If we run this script, we get the following result. Array at index 0 has the value dog, and array at index 1 has the value cat, which is just what we specified right here. Now let's say you want to delete something from an array. Well, in that case, awk has a delete keyword. Let's take a look at an example. If you want to delete something from an array, it's as simple as calling delete and then the array with the index you wish to delete. In this case, I'm going to delete index 0 and then I'm going to try to print the value of index 0. Small note here, in any other programming language, this would throw an error and would not work. It works in awk and it just prints nothing because we deleted that index. But keep that in mind. So, if I run this example, I get array at index 0 has the value dog, array at index 1 has the value cat. Those were those two prints. Now I'm going to execute delete and I'm going to print again. An array at index 0 has the value. And there you can see nothing. That is how you define an array, assign an element, and how you delete an element. Now I know what you're thinking. Doing everything by hand and typing out all those commands is very tedious. And yes, you're right. It's very inefficient, but when we're going to look at for loops later on, things will get much easier. Welcome to Chapter 5, where we will take a closer look at control flows. First of all, we're going to look at an if statement. An if statement in awk is defined as follows. You have the if keyword, then you have the condition defined in parentheses, and then in curly braces you have the action that you want to execute in case the condition is true. So, here we are defining two variables, x and y, and then we're checking if x is greater than y, then we want to print hello world. Well, x is greater than y, so this block of code gets executed, which we can check if we run it. That's pretty neat, but let's say we modify the following script. And we're gonna say that x is no longer 10, but it is 2. So now if we look at it, x is no longer greater than y. So if we execute our script, nothing happens. Well, we can also write a condition that checks what happens if x is smaller than y. And that is where we are going to use else if. First of all, I'm going to bring this down. And then I can say else if, and I can define a new condition. In this case, I can say if x is less than y. Again, curly braces. We are going to print hello Mars, just as an example. All right, let's take a look at our script again. We check for if x is greater than y. If that is true, we print hello world. And we also check for if x is less than y, in which case we will print hello Mars. So if we run the script, just as expected, we print hello Mars. But now there is another problem we need to solve. What if x and y are equal? That is a case we don't catch. Now, we could write another else if, where we check if those two are equal, or we could simply use an else block. An else block is always executed if the if conditions fail. So let's take a closer look at that. First of all, just gonna define else, curly braces. Then we're gonna say print you've reached the else block. And then we're gonna set the x to 5. All right. If we take a look at our script, we have an if condition that checks if x is greater than y, and if it is, prints hello world. If that fails, we check if x is less than y, and if that's the case, we print hello Mars. And then we have this else right here. This is what your code defaults to if none of the above conditions are met.
Welcome to lesson 5 on sed. Okay, let me clear this mess here for a second. So you can see that our test text that we made, we're going to replace every T with a capital T, right? Because we're using the /G after it. The /G means it's global, and the S means to search for this and replace it with this. So it could be anything. Like if you have script and you want to change it to a bypassing phrase, it'll change it to that for you. If you have a whole word list of payloads that you're trying to get past a web application firewall, that's how you would do it. You can use sed to encode your output to another tool. So this say this is coming from a output tool like get all URLs, right, or hat crawler, right, and it throws all kinds of URLs with a parameter and an equal sign after it, right? So we'll say s. What's the most common parameters? So we would identify the parameters, obviously, and we would go through each parameter and say, I want you to replace this parameter with this payload. And then I want you to take that into another tool, probably something like HTTPX, bring back the body of the request, right? And once you bring back the body of the request, you could check it for reflected parameters with your payload, right? So this turns into a pretty elegant way of seeing if you can manipulate parameters and if they will be reflected back to you in any way, right? I don't have much more on sed because this is usually what I use it for. I've done some research on it, and I can show you over here. Whoop, not there. Here. You can do all kinds of things with sed. You can delete text. You can print out the lines of a file, but we don't need that. We have cat. You can use address ranges with printing out lines. That's fine. Deleting text, that's okay. But substituting text when we're passing it is really what I use it for. You can see that, it'll only... So if you only wanted to change the second instance of your word, you could do that. You could say, I just want the second instance changed. You can pass the P option to substitute the print lines where substitution took place. You can print out all the lines that were substituted. Yeah, there's a lot of cool things you can do with regular expressions too. I'm just not really good at regular expressions, so that might be added on here later. But for right now, this is what I have on sed, and this is what I use it for. There is an entire awk lesson that will be, like I said, at the end of this, and it's wonderfully put together. So, whoa. So that's my lesson on sed. There's probably not going to be too much quizzing on this or anything. I just want you guys to know about it, so you can use it to your advantage. Okay. Next, we're going to look at scripting in Bash. We're going to write a script that is going to execute a tool that we have, and it's only going to execute the tool if a certain file has a certain domain in it. Let's say PayPal. Okay. Hello, everybody. Here is the lesson you all have been waiting for. This is scripting. Okay, I'm going to show you just what I've done here. Nano test script.sh. You look up here, you see a little hashtag. That's an exclamation point. That's a shebang or a hash bang. It's usually just to remember the process in which they go. It goes hash and then bang. And then you have bin and bash. If it was a Python script, it'd be bin Python. It's just identifying where we're going to run this text right here. Okay? This is just a simple for loop that takes it takes the output of this command right here. So we have backticks. Excuse me. We have backticks to mark that we're running a command. So for I in cat domains.txt, we're catting out the lines. We want you to do this command. But really what I want is I want something else. We can throw a grep in here and grep for PayPal only. Now it's just going to grep for PayPal and only pass PayPal domains through our crawler. Okay, this is an automated script, so let's go ahead and save it, and I'm going to show you guys what this turns out to be. There it goes. It found the PayPal link, and it's now scanning PayPal for all of its endpoints. Okay, we're going to stop it right there. Already, we have 84 kilobytes of information, and you can just automate any tool like this. Okay, let's go into our test script. We don't have any backticks around this statement here at all. You can put for loops in here. You can put if conditions in here. If you do put an if condition here, it'd be if condition, like if B equals A. Okay, and then it's going to say then cat domains dot text. Okay, and we'll go down here and say B equals A, and then we'll go at the bottom of this and say B equals B, and then we'll come down here and we'll say phi. Alright, that's going to run that as long as B equals A. It'll cat domains.text, and then once B equals B, it'll finish and it'll be done. You can put your if conditions inside of your for loops, inside of while loops, wherever you really want. And once you start to learn how to run commands inside of a bash script, you can automate all of your recon. Okay? The lessons have been leading up to this. So if you're in Udemy right now, your assignment is to write me an automated script that will actually execute. Write me an automated script that does something that you do for hacking, subdomain enumeration, filtering URLs, something like that. Write me a bash script that does that, and I'll run it. And if it runs, you'll be passed through the course. You can email it to me, or you can write it as a message. If you're on Podia, this is going to be one of the things that you have to pass to get your graduation. Is I want you to write an automated script and present it to me. You can send it to James at thexssrat.com. And good luck, guys. Good luck. These you have all the tools right here in front of you. This is the last video. That's why there's assignments at the end of it. And the next section of the course is all going to be bringing this together and assessing your guys's assignments. So have fun, self-learn, look stuff up, write the best script you can, and I hope to see you guys on the other side.